Yeah. Okay. Now, before you all leave and realize you're with the wrong Layla, I want a photo of you all. And I'm going to have to go precariously over here because you're kind of all spread out. And I will be very, very annoyed if you don't all wave at me. Really angry. You don't want to see me angry, okay? So, I want lovely smiley faces and big waves. Yay? Okay, that's good. All right, you can all go back to your poker faces. Alrighty, so you are here for building cloud-ready applications in .NET. If you are here for N-Service Bus, that's the other Layla. There's two of us, just in that room. I won't be offended, only mildly angry if you get up and leave now, okay? Good. You all know where you are. Wonderful. So I'm this Layla, this one. Oh God, I normally point this way, so I'm going to be pointing at NDC London, and you'll just all have to extrapolate where I'm pointing and hope for the best that you have figured out where I'm supposedly pointing. All right, I'm this Layla, I'm these things, I'm a developer advocate for .NET at VMware Tanzu. And you're like, well, what does VMware do with .NET? Well, it's Tanzu, which used to be Pivotal, and we have loads of Kubernetes stuff. I don't do Kubernetes. I don't do that. It blows my little brain. So there's stuff to do with Kubernetes on Tanzu. I do work there. And if you have any questions about that, you can ask me. I may not be able to answer, but it will all be good. I know the people who can answer your questions. What else am I? I'm an MVP, currently a GitHub star. I don't think I'll be renewed next cycle, which is next month, because they kick you out of the program after a year or two. So I'm well out now. And I am also the founder of the Women of .NET initiative. So if you are a woman, if you know a woman, your mum, your girlfriend, your sister, your daughter, who would be interested in learning .NET or talking to women in .NET, you can reach out to me, okay? So, oh, that was a bit loud. I feel like, are these on? Maybe not, I don't know. Oh, okay. I'm gonna waffle through this. I'm ditzy, I do a lot of live streaming, and I'm used to talking a lot, so you'll just have to follow along with me. But the first question you probably have, come on in, quick, that's it, chop, is what does cloud-ready absolutely mean? No, you're not allowed to leave, that's fine, okay. So what does cloud-ready mean? And you're probably wondering that, and you're stood here going, well, my app is cloud-ready, it's been deployed in the clouds for many years. So the actual cloud-ready part means any kind of legacy software program that has been modified to run on a cloud computing infrastructure. And I know there's a lot of different cloud this, cloud that, cloud overused every which way possible, but it is descriptive to what this is. And this is different from cloud native. Cloud native is more developed specifically to go on the cloud, not adapted from your weird old monolith to be brought on. So you're thinking, well, what's wrong with my app? I read your minds. You're like, my app is cloud ready. Of course it is. It's deployed on a cloud. But have a look at these questions here. And if you can relate to any of these, then maybe your app isn't as cloud ready as you think. Is it hard to scale? Are you struggling to scale vertically or horizontally and thinking, well, I'm scaling the whole thing and I don't really need umpteen versions or instances of this and that much CPU for that. And you're like, ugh, okay, but it's all there. I'll scale it all anyway, and it's expensive and difficult. Well, that's not completely cloud ready. Hard to maintain? Well, that's because everything is in one big lump and probably tightly coupled, so the other bit there. And when you come to do some changes, whether that's an individual or a team on something, you're maybe dependent on another team having deployed something or released something or updated something, or you can't just work on your own little bit of your application. You have to go and fix that bit and then that bit. And it's shaving the yak to the nth degree. So that's not cloud ready. Hard to release goes in with that again. I've already sort of covered that. If you've got your bit and it's all done, but you're waiting on that team to do something, and then you end up in the state that a company I used to work for was in. We deployed once in a year, 18 months, and we all had these features sat there waiting to go, going stale, going old. And oh, well, they're already out of date now. We've got to go and update them all, and it just keeps perpetuating. And that's not great either. Hard to monitor because maybe one bit's broken another bit, and you can't quite figure out what's doing what. And it's not resilient. If that monolith goes down, or one part of it goes down, it takes the whole lot down. And it's just not a great situation. Now, I'm not advocating for microservices here, okay? That's not necessarily where I'm going to send you either, and this isn't a microservices talk. We're going to talk a bit about modular monoliths and microservices, but I pre-warned you, this isn't a microservices talk. You don't have to run screaming. We're not going to do that. So let's take a look at this graph, which I stole from my work colleague, who in turn stole it from someone else who I can't remember the name of. But I drew this, so this is now mine, okay? And along the bottom, we have modularization, and up the side, we have a distribution. And your regular old monolith is probably this big ball of mud. It's all a little bit of, held together with clods of mud and straw, and it's hard to disentangle and separate into nice clean dirt and pieces of straw, and it's just not great. And you're like, well, it's really hard to scale this. We need to have multiple instances of it, and we're going to distribute it. But then you've gone up. You do not want to go up. You do not want a distributed big ball of mud because you have the worst of everything there. You will hate yourself and everyone you work with and your dog if you go that way, okay? So do not go vertically. So what you want to do is end up there eventually, or have the option to go there if you need to. You may never go there, and that is okay. And how you go there, you don't go that way, you go that way. You go along the route of modularization, and you start to break things into individual, independent units of stuff. Because that could be whatever. That's why I call it stuff. It might be a service, it might be a client, it might be a database, whatever it is. It's stuff that's independent or very loosely coupled. So you want to go that way, and it's still a monolith because you maybe deploy it all together or something like that. It's still got that essence of monolith, and you're not quite at microservices, all those independent things, millions of them all being deployed in different ways, 15 times a second, whatever ASOS are doing. That scares me when I see their figures for deployment. I'm like, wow, okay. But you can eventually go to microservices if you so desire. So that's a good, happy path to go to. Do not go straight up. Okay, so I want to talk to you about implementations. I've done talks on the whys and the big pictures and the theories. I'm going to show you code today. I'm not going to live code much. I normally do a lot of live coding, but we're going to put some breakpoints in and go through some code, and I'm going to show you some bits because I think that you're going to get the most from that. And so we're going to touch on various bits of things that make your application cloud ready when you bring them all together, and configuration is our first one. And I'm going to talk about external configuration because when you have lots of different things going on and instances, a really easy thing is to extract your configuration out of all these different apps and have it centralized. And it could look like this. You have all of your services, you have cloud storage, databases, their connection strings are in there, whatever you need. And then you've got this store in the middle. You can cache it so it's lightning fast. And you can have all of this. And it has plenty of benefits. We clicked on one too many there. Spoiler alert, doxed myself with the doxing thing. So you can update your apps without downtime. I've just released something 2 weeks ago onto an Azure Web App Service. I had to keep refreshing my app secrets. So I'm in there in the environment variables and putting them in, and then I have to do that. Oh, your app will now restart now. Okay. If I'd had it externally configured, it wouldn't need to restart. Okay, so you do have to do some various things in your code to make it support this, but you can have all of your instances all grabbing from this central store, and that also means that they're all running the same configuration. You haven't updated one instance and forgotten about that one over there, and now you've got this mismatch. You can share your configuration, your duplicated configuration across multiple applications, which also means you've got less chance of errors and things like that. And you've got versioning, because I don't know if you've done it, but you go in and you change everything in your configuration and you're like, oops, that wasn't right. And then you have to go all the way back through it. It's really tedious. And well, you could just roll back, or you could, if you've done a deploy and you need to roll back that deploy, you can go back to your previous configuration as well. So it's a really sort of easy win. They aren't necessarily inherently secret. Do not dox yourself. There are ways to make stuff secret, but it doesn't need to be secret. Might not be secret out the box just because you're going to put your app secrets in it. Just be aware, okay, that it may not be secret. So some providers, you can just stick it in blob storage, easy. You can have Azure App Configuration, Spring Cloud Config Server, there's Kubernetes config maps. Don't ask me about them, I don't do Kubernetes. And there's more. If you want secrets, you can use like Azure Key Vault, or any service like that that you've heard has centralized key value pair type stuff. So that's a quick whiz around configuration. All right, so messaging. I told you this is going to be quick. I've got a lot to get through. Okay, we're 10 minutes in, all right. So messaging is a big part of having nice, resilient, separated, independent services and things like that. And your services are going to need to talk to each other, and messaging is a really good way. And I'm not going to go into too much depth. I think there's like 3 or 4 talks here specifically on messaging. But the gist of it is that you have a producer that's going to create a message. It's going to enqueue it. And then you have your message queue. And then your consumer that is waiting on this message is going to dequeue it. So it kind of looks like this. And then I'm going to have to cough again. Excuse me. Okay, so why messaging? Well, you can talk to many different clients at once, and so that's broadcasting. It's really easy. You can just send it all out from your producer. The producer doesn't care who's going to listen to it. It's just like, here is my information. Like all of you, I'm producing the information. You're all lots of different people consuming my broadcast. Now, multicasting is easy. I don't want to talk to you lot. I'm going to talk to all of you over here. I'm going to multicast this way and not to you lot. So we can do all of that. We can group it. We can do it broadly, whatever we want. Now, temporal coupling is eliminated because I don't care when people receive my information. People watching in a couple of weeks on YouTube, well, I don't mind if they've watched it in a few weeks. You've watched it now, they're picking it up in a few weeks. That's okay. It's that kind of thing. We're going to just fire and forget for all you gamers. It's that rocket going off and you don't worry about it anymore. Logical coupling is eliminated because you don't need to have all the logic in there and it can all be separated. Spatial coupling, again, you don't have to have things co-located in the same thing. They can be off elsewhere. And it gives you built-in throttling because if I put stuff on the queue and you're consuming it, you're like, I'm not finished with this process yet, so it's great for long-running processes, because you can load it up, and that consumer can be like, oh, I'm fixing this, I'm processing this image, I'm writing this PDF, long-winded stuff. And it's like, okay, that's done, I'll get the next message. Meanwhile, the producer who's like whizzing along can just shove everything on this queue. So it's really nice in that respect. So why not? Basically, everything on this slide means it's a little bit harder to implement, look after, debug. So be sure that you need it. If you are going distributed, you probably do, and you're already going distributed. Your complication just went up here anyway, so why not add a little bit more fuel to that fire? So it can be complicated to implement. There's lots of moving parts. You've got to think about dead lettering, what to do with acknowledged things. There's a whole load of stuff going on that you need to think about. There are libraries that can wrapper that and obfuscate it for you if you wish, or you can just go through the documentation and do it yourself. It's hard to see how things communicate with each other. It's harder to debug, not impossible, but it's just a little bit harder. And you've got more bits in your whole infrastructure, more places for failure, more things to go wrong. So I'm going to show you a quick demo with RabbitMQ. Now, RabbitMQ is owned by VMware. It's an open source product. But I always like to use RabbitMQ because my very first engineering job, I used RabbitMQ. I was like this new .NET dev, and I'm like, I don't know anything. And oh, here, you're going to program this queue to write PDFs. And it's like, oh, I am. So I didn't break it as a new dev. So I think it's pretty user-friendly and easy. So this is what I'm going to show you. All of my demos relate to food. I hope none of you are too sleepy after the yummy food you've just had. And so let's just say we have an order coming in. That's number one. It goes to our order service. That's our producer. I'm going to lose my voice now. And we're going to do a topic exchange, which is a publish, subscribe model, okay? So we're going to have something published to it, and then we'll have a subscriber. So it's only, not everything is getting the broadcast, only things that want to know about it, okay? So that's what a pub sub is, and this is a topic exchange, which is the RabbitMQ name for a pub sub. So you have a routing key, which is like, this is my tag, I'm going to be about cooking waffles. And then our consumer, which is the kitchen service, is looking for anything to do with cooking waffles. It's like, oh, okay, I'm a waffle cooking kitchen service. That's a waffle cooking message. I'm going to grab it. And then I just use Signal R to publish it, because we don't want our chefs having to press any key buttons to refresh. They should be focusing on waffle creation. So we don't want them to touch anything. So that's it. I'm going to show you that code. So let us head on over to this demo. Now, let's have a quick look. Steve, is that big enough? Good, okay. So let's have a look. This is .NET 6 or .NET 5, doesn't matter. Oh no, it's .NET 6 for sure. It's .NET 6 or .NET 7. I can't remember which. So it's all the same at the moment. So I have some abstractions here. Maybe this would be in your own NuGet package. I have some settings that I need to set up my Rabbit connection. And then I have an extension for my iService collection here. Now, Steve over there in the back corner helped me write this because he's like the disposable king. That sounds terrible. I'm sorry. You're not disposable. You just know a lot about disposable, iDisposable and stuff. So Steve helped me figure this out. So if you see something wrong in it, it's his fault, not mine. So this, we take our settings, we bind them, we add them as a singleton, and then we start to do our connection. And down here, this is the bit more that we're interested in. We create a channel, that's our open chit-chat channel to our queue, and we say, right, it's this exchange I want to listen to, and here is my settings, it's a topic exchange. You could put all other information here, this is the bare minimum, and then we set up that channel, and then we dispose. Thanks, Steve. So we go over here, and we're going to use that in both of our services, which is the order service and the kitchen service. So let's go into the order service first. And I have used that setup rabbit MQ just to get that there. And we have this rabbit sender because this is the producer. So if we go in here, we've got some rabbit settings. And basically, I have a generic publish message. It's going to serialize the message model. It's going to encode it, and then it's going to publish it to our topic exchange. Okay, so that's that side. That's the producer, and all of this code is on GitHub, so don't worry. And then we have a excuse me. We've got the consumer, our kitchen service, and that is added exactly the same way in here. We've got the setup rabbit MQ, and we have this rabbit receiver. And I've got this as a hosted service, so it can always be listening. It's always listening. It's creepy. It's a creeper. And so it starts. This is all the iHosted service interface stuff. And down here, we're setting up the channel it's going to listen to. And then we bind it, and we're telling it, you need to listen for this key. That's the cook waffle key. That's what it's interested in. And then we have an event here where we just say, when a message comes in, just do it. And this is all the SignalR stuff, the order hub. So it comes in, it deserializes it to an order. So that's shared between them. That's a bit of shared configuration. And then we can acknowledge it. It's good to acknowledge things manually. Someone on the Rabbit team told me that. The demos will show you auto-act true. And he said to do it false, so you can make sure that you're handling it at the right time and it's not being acknowledged if you have exceptions and things like that. So we acknowledge it, which means, hey, producer and queue, well, not the producer, just the queue. I've done this. You can do whatever you're configured to do with a consumed message. Dispose it, store it, whatever. Okay, so we have that. Now, before I run this, we have to go over here and destroy this little laptop. This laptop's 5 years old, from 2018. And I think it's this one. We're going to run RabbitMQ with the management studio in it. So you can do that for local testing. You can run it in a container. You can get Rabbit as a service on Azure and a function. You can get it in lots of different places, or you can use Service Bus, Azure Service Bus, Kafka, whatever you want to use as your service. So that is now running. And with the management container image, you get this whoosh in here. This is the RabbitMQ exchange. Now, do we have it? No, we can go. We don't have a topic yet because I haven't run it. I was just checking. Sometimes it hangs on to it. So let's go and run this. Excuse me. All right. So if I go back now over to Rabbit, we should see our topic exchange registered. Waffle messaging, there's our topic, we've registered it. So you can start to do a little bit of debugging and monitoring. And then if we go back over here, here's my Blazor app. That's going to be the kitchen service. And then we can just do a little test of that. I think I've got some breakpoints ready. And, well, let's just go and execute that. So you can see here, it's come in, it's going to publish it. It's gone through, we had our model here, it's serialized it. It's going to say, right, we're going to publish it to that topic exchange. And if I let that go, you can see now I've hit the receiver in the other application, and that's going to publish it over to SignalR. And if I go and show you here, you can see that it's done it. So it's really quick. I know it's local, but it is still really quick if it's published. And you can just keep going. If I got rid of those breakpoints. And that's it. It's really straightforward. I say that, you need to have a little bit of knowledge and help. And you can see that that just keeps sending through those. I have a seed on that. And if we go back over here, we'll probably, if I go to, if I dig into this, you can see there's our messages. So you can get a lot of information out of the RabbitMQ interface. Okay, so let's go on here. And if you want to go through that code in more detail, I have a blog post on it that you can go to here. It tells you all the details, much more detail, and gets you set up, so you can go and get that there. Next, service discovery. Okay, so this is really important when you start to scale. Let's say you walk up to your telephone. You don't have your mobile on you, and you want to call for a pizza. How do you get the number? Anybody? No, you don't know it off by heart. You're not that much of a pizza fan. Well, you need a phone book, don't you? Yes. Anyone? You remember those? They used to get delivered. They used to be this thick, and then they got thinner and thinner and thinner and thinner, and now you don't get them at all. But that's what service discovery is. So if you have multiple instances of your app, or just multiple apps, how do you know what their IP address is? How do you direct your traffic through to it? How? Service discovery. Service discovery. See, it's in the name. So this is what it looks like. I've got all my instances of a service, and they all go and register with my discovery client. That's my phone book. And then me, the client, wanting my pizza, I say, hey, can you give me an instance of the pizza? And it will go, yeah, here, go here. And it will give me the IP address of it. And that's what happens in stage 3. And this is really cool, and it's, you know, there's a lot of providers out there. But it's a really important step if you're going to scale and distribute your applications. Now, probably some of these Azure and cloud things will do it for you, but if you're rolling your own, you're going to need to think about this. So it can also do your load balancing, because you can program your code or the provider to do round robin or load balancing in whichever way you want. So you're combining lots of different things, because if you look at this diagram of a load balancer, it looks kind of like that, doesn't it? So it can do that, and you've probably, I'm sure most of you have heard of load balancers. You can do that with monoliths. You can have 2 instances of it and switch between them, or you can do that with as many services as you have. So you can combine the 2. And we're building up to something, okay, just letting you know. And we're going to do a demo with Steeltoe and Netflix Eureka. Now, Netflix use their service discovery for all of their services. They wrote something called Eureka. And Steeltoe, which is another open source project from VMware, and I work closely with the team, has a amazingly couple of lines of code thing to get you connected. So I'm going to show you that, because I think it's really cool. I'm not just saying that because I work for them, because if it wasn't cool, I wouldn't say it, which gets me in trouble. So it's all good. It's all good. So let's go and open that demo. I'm too scared to open multiple instances of Visual Studio on this laptop. So we're just going to have to open. And then we go this one, and then I want to show you service discovery. Okay, alrighty, so let's go and have a little quick look-see in here. So I have 2 projects. I've got this dad joke API, so be prepared to laugh, belly laughs, big, hold those full bellies and laugh, because they're hysterical, I hope. And I have that. And we're going to create 2 instances of that in a moment. If I go and have a look at the project file, you can see I've got Steeltoe, Common Hosting, and Discovery Eureka. Now, there are lots of services that will do service discovery for you out there. I just like Eureka, but there's HashiCorp, have one. In my other talk, I list loads of them more. So we have it in there. And then in our app settings, we need a little bit of that. And that's just these few lines. And I have, should it register? Do you want it to go into your phone book? Yes. Can it have access to the phone book? Yes. because you may not always need that access. And then in the program, this is the great thing, okay? That's it. One line, yay, how cool is that? Just one line to do all of that registration. Now, if we head over to this one, again, this is going to consume it. We still have our app settings, and then we have a program. And again, look, one line, and we've got connection to Eureka. That's it. That's all you need. And then if I go into this is just going to show you some of the things you can do with Eureka. And again, a hosted service. It's going to be delivering you jokes every few moments. Hurrah. So you can inject the discovery client because we've added it to services, and then that gives you access to it. And, well, let's just run it, and I'll put a breakpoint in. Let's see, let's just bung one in there. And just like Rabbit, we need to have a container. So, there we go. So we have a Eureka container. That one's built with Spring, because I stole it from a colleague. They're all Spring developers. And then once that's up and running, we have a little thing to go and have a look at. Oh, emergency. Wow, we'll just scroll past that. We can see no instances are currently registered. Let's change that. So if we go back over here, you can go. You're not anything. I don't know who you are. Okay. And you are totally not what I want to do. Oh, I can go, but that's for another demo in a minute. We'll go back over here, flick, flick, flick. Okay. Right, so that's instance 1 on port 5006. This is going to be instance 2 on port 5001. So I could go directly to those ports and get my dad joke, but let's go get it via the demo. So we'll run this, and hopefully you're all going to laugh at the jokes. They're not mine, so it's fine. So let's step in. And in here, you can see I've got one app registered. I was hoping we'd have more, but, you know. That's really small, but it says there's a count of 1, and it's the Dad Joke API. So let's just go and have a quick look at what Eureka says if one of them didn't register properly. No, they're both there. So you can see straight away it's registered with Eureka. We've got the 2 instances and their ports. Okay, so if we go back into the code, let's just run it. Oh, so I'm just going to let that go because we've backed up. We've got jokes galore. I thought that might happen because I saw only one. I think I may have started this too soon to get both instances. Okay, all right, there we go. So let's see. Oh, yes, here we go. So you can see here, it's gone and got our instances. So the instance 1 is on 5006. Instance 2, they've both got the same name, is on 5005. So if you wanted to consume this, you would say, hey, Eureka, can you give me Dad Joke API? And it would just give you an instance of that. You could get the first, okay? And I'm not even going to read these. They're for your enjoyment to read silently in your head and chuckle, okay? I don't want to know what they say, because sometimes they're that bad. So you can see here it's actually randomly selecting which one it's going to call. So for those of you at the back, we've got 5005, 5005, 5006, 5005. So it's just randomly going and getting a different IP address, let's call it, for the service for the instance. So there's our phone directory, which is really cool. Well, I think it's cool, but then, you know, it's fine. Let's go back. And again, let's go over here. I'm trying to give you a whirlwind tour. Like when I went to see the Mona Lisa at the Louvre, there's the Mona Lisa as you whiz by. That's kind of what I'm doing for you all now. So we've had this demo, and it leads us on to API gateways, because that's going to combine a lot of the things we've just talked about. Yay. So we've got, without API gateways, we've got all of our services. And if the internet was going to talk to all of our services, it's going to make a request to service 1, and you're going to have to secure that and do all your stuff that you need to do when someone comes and talks to your app. You're going to need to do it for each service, and that seems horrific. Or if you've got a client consuming all of these, it's going to have to go and call each one, and that just seems like a pain and a recipe for error. So if we put a gateway in, we've got that one point of entry to your application. That makes it easy to secure. You can have all of that centralized security there. You can do your identity. You can do all of your load balancing. You can do your service discovery. Everything can happen in there and then go off to your services. So it's a really useful thing that builds on the last 2 things that we've just looked at. And you can bring it all into your API gateway. And this is its own application. We'll see, it will become more clear when I show you the demo. And there's lots of different versions of this. I would like to show you my preferred one, which is YARP, yet another reverse proxy, from folks at Microsoft, another open source project. You notice how I'm trying to share open source projects with you, and not anything that you would have to go paid for. Unless you got really big, then you might have to pay for stuff. But at the moment, you can go and play with everything here. So API Gateway can combine lots of different things, and there's loads and loads and loads of benefits to it. And it should be your entry point, whether you've got one monolith or lots, because it's just a nice abstraction layer. You can do all sorts of things with it. But let's go and have a look at a demo with YARP, because I just prefer to show you code and talk you through it, because I think it's like a picture's worth 1,000 words, isn't it? If I could put bullet points on there, but if I go and talk you through an app, I think you might get a clearer picture. So let's go and open a project again, and we're going to go into this one. No, I don't want to rename it. Okay. So let's have a quick look at what's going on in here. Guess what? It's about food again. Yay. Alrighty, so I'm going to ignore the gateway project for now. At the moment, I have a client, and this here is a Blazor server app, I think. I can't remember. Doesn't matter, not important. And if we just go and have a look in here, our client is, that's not the right program file. I've got 2 named HTTP clients in here. I have a food service and a drink service. And you can see that they've got the ports in there, different ports, and that's our situation without the API gateway. Your client is going to have to call lots of different things, and each one of these is going to have its own built-in security and identity and stuff because it's coming to a different address. And that just gets consumed here. We're just going to go and get a food item and a drink item. And then we've got our drink service, and that's just going to dish up a drink randomly, and the food service. So I'm going to run it. So this doesn't have the API gateway in place. It takes a few moments. Remember, elderly, well-loved laptop. I mean, it's not, I've hardly used it. I have a Mac normally, and the Mac was mean to me last week. Anyone else having difficulty with their certificates, self-signed certificates locally? Just me? Okay, I see that head. It's just me. Okay. Well, I rage quit the Mac and moved onto the PC so that you wouldn't have to see me enter my password gajillion times wrong. So you can see it's gone and got chips and dip and tea. Ugh. That's a horrible mixture, sorry. Or a fish taco and tea. Meat taco and coffee. Really, oh my goodness, I'm not eating here. But you can see that it's gone to both places. That's really just made me feel a bit unpleasant. All right, so that's without the API gateway. Let's just minimize those. And let's go and have a look at what you can do with a gateway. Gateway? Yes, API gateway. So this has YARP in it. If we go and look at the CS proj here, You can see I've just got YARP reverse proxy in here, nothing else. And then there are some instructions. I've got libman in here for it needed it, I think. I don't know why. I can't recall, but you can go and have a look at the documentation. So there's a few things in here that you need to do, and you add it as a service, and then you go and build from your configuration, because there are two ways that you can do your configuring here. You can do it in configuration, or you can do it in code. So here is in configuration. So we're telling it to go and load from config, which if we go and look in our app settings is here. But I'm going to come back to that in a moment, because that's the first part of it. And then we need to go and map the endpoints. So this is all just in the documentation straight up out of it that you will put the endpoints in. And that is the reverse proxy NuGet package that we're using. So let's go and have a closer look at the app settings. Let's just ignore those. Now it starts here with your reverse proxy, and we have the routes. So this is where you're going to describe how the API gateway is going to talk to the services you're redirecting it to. So this is our food service and our drink service, okay? So this one here, sorry, that's the other way around. This is what our client is going to call to get to it. This is a real catch-all wild card. Any old thing can come through. You can be so descriptive on this. You can really go down to some granularity here. So I'm going to say anything that comes to the endpoint food service, shove on this way, okay? Shove it over to the cluster with ID food service. Okay, anything at all. And I say you can be quite granular. Doing the same with drink service. Anything that comes into drink service, toss it all over to the drink cluster. And down here, I'm going to define my clusters. And you can see there's destinations in here, so you can do all your load balancing and all that whizzy stuff down here. And here's my food cluster. Remember, this was food cluster. So now you have to go and define that food cluster. And I give it the actual IP address. Same with the drink cluster. So now you're like, oh, but what if we've got service discovery? Don't worry, that all can come into it. Not a problem. So we've got that, but how do we now get our client to use that? Well, if we go and check the launch settings of this, it's on port 5001. So let's go over here. I'm going to change this to 5001 now, because we only want our client to talk to our API gateway and not to our stuff directly. And then I'm going to say this one is the food service, so I want this to talk to the food service route. And this one down here is our drink service, so that's going to speak to our drink service route. Okay, so we got that from our app settings. Let's go and run this. And hopefully you should see no difference, except maybe not meat and tea. Tea and meat tacos. Ew. All right. So you can see that's our endpoint, the food service endpoint, because I've got them all opening, tea. And then here is our client. So this should be talking to the API gateway now. Yay! So you can see it's just gone and done it completely on its own. Not on its own, I added some configuration, but it's now talking to the API gateway. We've got one place where it's coming in. It's not talking to all these different things. You can secure one place. You could just have one HTTP client there, and you could just have one for that service there, and then you can do your endpoints within your strongly typed HTTP instead of having multiple clients. So, you know, less work, and it's just more configurable and more desirable. So that's with YARP. Now, because I want to get through all of this and not run over, because I've got to go straight to another session after this. Whew. I have popped in the link. I have 2 blog posts, one that goes through that app that I just showed you, .NET 6 and YARP, And then the second one, which brings service discovery. And let me just make that bigger. So with the Eureka, that now does a whole load of code configuration. So we saw app settings configuration. That one goes through with code, and it updates from Eureka every few moments to update those cluster paths, okay? So it's really cool, and again, that's combining everything. So now you can start to bring in your service discovery, API gateway, and load balancing all into one, okay? So you can start to see how you're building this cloud-ready application. Which brings us on to resiliency, because we need it to be resilient. There's no point doing all this wonderfulness if it's just going to go and fall over, is there? So we want it to be resilient. We're going to look at HTTP resiliency, because that's what we've built. And that's having a way that your app can fail gracefully. Okay, we don't want it to just give like a horrible error to your client, your user, maybe not even an error at all. We maybe want to have some backup data that it's going to get from somewhere else if it can't talk to the HTTP service it was going to talk to. So we're going to look at the Polly project. And if you go onto their website, they have the best chart. I had to steal it. You see, I'm stealing stuff from people. Look at this, also known as retry. Maybe it's just a blip. I think more things should give you a layman's term for what they're trying to go, because, you know, so often you go in there, many faults are transient and may self-correct after a short delay. Okay, maybe it's just a blip. That's so much more descriptive, isn't it? Well, I think so. So we've got circuit breaker, we've got fallback, that's the degrading gracefully. They have loads of stuff in here, bulkhead isolation, rate limiting, caching, and then a way to wrap them all up together. And you can put these patterns into place for anything when you're doing a database call or anything where you might have a failure. I say we're going to just look at HTTP, but just bear that in mind that you can do this resiliency for any call within your application. All right, so let's consider service A, and it's making requests to service B. Live footage of service B. It is not dealing with requests at all well, okay? Not well. It's underneath all these requests, and what are we going to do? That's just going to be some 500 error. It's all going to go kaput. We're not very happy with that. So we're going to put in a circuit breaker pattern. We're going to do this in code in a moment. And this comes from electrical circuits. Closed is good. This can be a little bit of a head twister. So when everything's going and service B is dealing with all of its requests, it's closed. When we have a developer-defined failure threshold, and that's exceeded, it pops open. Just like when you overload your circuits at home and your circuit breaker goes, okay? So that's now open. No requests are going through. And we can have a cool down moment. We'll let that service B get its bleep together and get on with it, okay? It really just needs to have a little moment. Maybe whatever manages your instances needs to create a new instance. You know, things like that. It just needs a little bit of a time. So after some delay, we're going to half open that circuit, which means I'm just going to send one request. Dip that toe in the water. Is it actually going to accept it? And you'll have two outcomes. Either it will fail again, in which case we open the circuit, or it will be success, we close the circuit, business as usual. So let's see a demo with Polly. And I'm not going to do straight up Polly. I'm going to use the HTTP extensions version because I think I've never used Windows 11 before either, so this is just a disaster. If you're going to use Polly for your HTTP requests, I think you'll probably end up using the HTTP extensions because it's just really nice to use, and a lot of the hard stuff is already sorted for you. So let's go on over and have a look and go in here. So I have a nice API running over here, this one. And this is an Azure function, and this is going to sporadically, at random, fail. So let's just have that running in the background. Let's just check that that goes all running. Yay, okay, so we've got an endpoint there, 7198, because it doesn't like to use 7071 for some reason, 7198, cool. So in this application, this is .NET 7, I believe. I have a strongly typed service. And this service is going to make a GET request to that function to get some ingredients to go on our waffles. I should have done this talk yesterday when there actually were waffles to go outside and eat. I do apologize. I'm going to give you a craving for waffles. And so let's go and look at in our program. And I've added just an extension method to iService collection to bring in our policies, just so they're not dumped into my program. If you want to know more about that, come to my workshop, which is immediately after this session. So let's go and have a look at some policies. We're going to look at retry, fallback, and circuit breaker. And you can see here is our client and our strongly typed waffle service. And you can do a different policy for each service you have. You can have a general one. You can be very specific. So it's really nice in that respect. So I've got a retry policy down here. And I've actually got two types here. I've got a basic one. And you can see we're using the HTTP policy extensions. It's going to handle some error. And it's going to retry 3 times. I also have a bit more of a fancy schmancy one, which we're going to use in a minute. And this will listen for HTTP response messages. And if it doesn't have a success code or it can't be found, it's going to retry 3 times. And between each time, it's going to allow a little bit more time. Okay, so it'll be like 20 seconds, 40 seconds, 60 seconds. And you can define all of that and more. So that is a retry. And then we have a circuit breaker. So that was what I just described in the slides. And we're just going to look at the fancy schmancy one. And again, just like before, we have an HTTP response message called circuit breaker policy. And this is going to handle a request from HTTP response message. And on internal service error, is server error, not service, it's going to open the circuit. Okay, it's going to wait for 3 failed attempts. So you can have all sorts of granularity here. And then after 20 seconds, it will allow that half-open stage. And you can set that. And then for logging, you can have things happen on break, on reset, on half-open. So you can see down here, we've got some stuff going on. And then the final one, if all else fails, we have a fallback policy. And this may be, I don't know, you're going to dish them up some ingredients that you always have, perhaps. I don't know, whatever you would need, or an error message that's like, hey, sorry, we're shut, come back later. No waffles today, like you're going to have today. No waffles today. You can have cheesecake. Disgusting. Sorry, don't like cheesecake. So that's our fallback policy today, cheesecake. Yum. All right, so I have combined them all into this one here. And this is a cool thing. Again, it comes with our HTTP extensions. And it's a wrapper. And we've grabbed those 3 fancy ones that I showed you, and we've wrapped them. And the order does matter, okay? So look at the order that you need it to do, because it goes along them and then back up it. And there's a really great blog post on the Twilio blog that goes into depth into policies and Polly and tells you all about the order. So I strongly recommend go check out the Twilio blog because I found that really helped me understand a lot about it. So I'm actually going to show you this one now. So I've wrapped the policy in here. You can see I'm using that extension, and we're going to run it. I've got this little thing here which goes and gets that waffle service. So let's see if I can bring up that's the function. Don't worry, I'm going to make it bigger. Hang on. I want you to see the errors come in. Okay, so let's do a try on this. Execute. Okay, all right, so we got an error. Let's trying again. All is good, okay? So we didn't hit that failure threshold, that was 3. And if we go down here, we've probably got some ingredients somewhere. I don't know, it's probably because I don't know where they are, but it was successful, so that's fine. Let's try and see if we can hit that again. So that, you can see, was our retry. Nothing came in there because that one was successful. It's going to do it to me, isn't it? Let's see. Go on, error again. Yes. All right, so we've got our 3 errors. All right, let's make this big. So we hit our threshold of 3 errors. We did our 3 retries. And you can see here, I've left all the errors out there for you to see. Circuit broken exception. The circuit is now open and is not allowing calls. So we hit that policy kicked in. And now you've got that. You can do whatever you plan to do if you need that. Now, I've got that set to 20 seconds, so we might be able to try it again. Yep, we did, and it was successful, okay? So now our circuit is back open. If that one had failed, it would have gone from its half-open stage to its open stage again. So you can start to see how they come in, and whew, we're really right up to the line here. I hope you weren't thinking of slinking out of here early and doing something, because you don't have time. All right, let's go to the last thing I want to talk about, and we'll whiz through here. Monitoring. This is really, 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 really important. When you've got distributed things and your complexity has grown, you need to monitor all the things. Just have that in your head. Monitor all the things. Repeat it back to me in your head. You don't have to speak it out. It's okay. I'm not going to make you speak. But think, monitor all the things. So it involves the collection, interpretation, and display of information concerning the interactions among concurrently executive processes. Ugh, it just means monitor all the things. You need to know what's going on with all of your apps. So I was going to have, oh, we've got time. We're going to do it. I'm going to show you super quickly. You can go. Let's open this. A quick bit of monitoring with Steeltoe, because I like to live dangerously. Okay, so Steeltoe has some really nice, easy endpoints. You can add a health actuator, so that's a health endpoint. I've just got the Steeltoe stuff. I won't go into the CS prod. I can add all actuators, info actuators, distributed tracing. It's really good just to get this straight in, because well, how would you monitor everything? Would you go into each bit of it and put your logging in there, maybe? Wouldn't it be nice if you could have something just crawl everything and print it to the screen with a couple of lines of code? Yes, Layla, that would be amazing. And that's what you can do with the monitoring on Steeltoe. And let me just show you this in work. In work? That's terrible. In practice. Okay, so I'm going to hit this endpoint. It's just the default one there. You can see the get weather forecast endpoint was just triggered. That's just from the Steeltoe monitoring. It gives you details of that. You know, you can do that again. You know, that's just some of the monitoring we've got in there, but we can also go and get actuator. Did I spell that right? Actuator. Oh, look, it's coming up. Thank goodness for that. And this is now my status. You can give this to your SRE, site reliability engineers, and they can connect to this and connect it to their Prometheus or their monitoring thing. And you can see, well, here's the status of that service. It's ready. It's accepting traffic. So they can start pulling that out. One line of code. One line of code did that. You can bring up all actuators. Let me just show you the distributed tracing bit quickly. I'll give you links to this so you can go in and play. So if we did that, I think we will get stuff in here. I don't think, I know we'll get stuff in there. So let's try it out. We can execute it. And if I go back into here, we should have got some more information. I can quite often, I don't know why that's not working, maybe I didn't save. I should have done it. But we would have got the information that I got from the endpoint in your tracing, in your logging. So you can have that all in there. And you can start to bring that in. And I am at time. So we're going to whiz back over here. And I'm going to whiz you through those last few things. Those are all the endpoints that you can get with Steeltoe. And here are some other considerations. Security, 12 factors, testing, scalability, and distributed tracing. We touched on that very briefly just then and failed. 12 factors, we did touch on a lot of things. I don't see this talked about much in the .NET environment, the 12 factors, but you can go and research these things. I just dumped them there. I don't expect you to be able to read them at the back because I know it's small. But just remember, go and look at the 12 factors. When you are building these applications, you want to start thinking about these. That's what we've kind of been secretly touching on. And then there are the links, right? That's what you want a picture of. Okay, that's got my slides, and then everything else is fine. If you just get that bit.ly cloud-ready apps, you're golden. Links to everything else. I'm just letting you all do it. I see the cameras going. Okay, good, good. And then, phew, thank you. That was a whirlwind. Thank you so much for sticking with me. You can find me at all these places. I've got layla.dev, YouTube. I'm Layla Codes at Twitter. I'm Layla Codes at Mastodon is difficult. You can find that from my Twitter. And GitHub, where this lives, is Layla-P. Thank you so much. Enjoy the rest of NDC.